Kirk with math. All right, ladies and gentlemen, welcome to 4.5. We're graphing systems of inequalities now. Don't forget to smash that like button and turn on that notification bell so that you can get notifications every time Kirkwood Math posts. We are here on page 94 and 95 of your student companion. We're going to start here by showing you what happens when I graph a system of linear equations, which means that I'm going to have inequalities, which means I'm going to have two inequalities to graph. So a system of linear inequalities is made up of two or more linear inequalities. The solution is going to be all of the ordered pairs that make all of the inequalities true. So here are the solutions separately. So here is this line right here. We're going to go ahead and graph that, and you can see, I'm going to zoom in. There we go. So on this one, you can go ahead and see here's the line, and everything above this line is a solution to our first inequality. Our second inequality is here at a negative slope, and everything on this line or below is a solution to this inequality. And when I put them together, I now can see the two shaded areas. So when you're doing this on paper, you're going to want to shade, you can do two different colors, but we don't always have two different colors with us. So what mathematicians usually do is they'll shade one of their inequalities with lines going in one direction, and the other inequality with lines going in the opposite direction. And you can see that anywhere that the lines are crossed, anywhere that you have this crisscross is going to be the solution of both of your inequalities. Of course, if you are using your textbook or you are using colors, then you're looking for the area that's double shaded, okay? All right, and just like all of our inequalities and equations, we can have multiple different types of solutions. So if you have two parallel lines, okay, and their shading is going in opposite directions, you can have a system of linear inequalities that has no solution, okay? So if their slopes are the same, their y-intercepts are different, and their signs are opposite, okay, then you are most likely going to have no solution. Now, it could be that this line would be down here, this line's over here, and so they might overlap in the middle, so you have to really pay attention to the graphing of this, but you can have it so that these parallel lines do not intersect. All right, so grab that graph paper, head on over to Desmos Online, and give yourself a try at graphing these systems of inequalities. So you are going to go ahead and try to graph these systems and see where they overlap, as well as this one as well. So you've got two sets of inequalities to graph and identify those boundary lines and figure out its shading to see where our solutions are. All right, in example 2, we're going to go ahead and look at a graph of inequalities, and we are going to take a look at what is the system, okay? So when you are given a graph, you're going to do the same thing we did in 4.4, except that you're just doing it with two lines, right? Oh, pause for a second while the 4-year-old interrupts. Okay, I'm back. So as I was saying, it's the same thing we did in 4.4, except that you're doing them with two lines. You're just going to identify this inequality as a line, and you're going to identify this inequality as a line. Make sure you pay attention to where they're shaded and if they're dotted or solid, and then you should be able to write those solutions, okay? So the solution to the red line is y is less than 2x plus 3. The solution to the blue line is y is greater than or equal to negative x plus 4. And then here, this little fancy bracket here, this is how we show that these two inequalities, or even equations, you could use them for equations as well, but that those are connected in a system or a set. Okay, so that they're connected together. If I just had two equations separately, it doesn't necessarily mean that they're together, but that bracket, that's kind of what it's showing here. So the answer to this graph would be both of these inequalities. All right, so now it's your turn. Can you go ahead and write the equation or inequality for each of these lines with the proper shading placed, and write them in your student companion for both A and B, and we will check them next time I see you. All right, our example 3 is now looking at our word problems. We always get those real world problems. So here we have Malia. She has $500 to purchase water bottles and pairs of socks for a fundraiser for her school's cross-country team. She needs to buy a total of at least 200 items without buying too many of just one item. What graph shows the possible number of water bottles and pairs of socks that Malia should buy? So the picture tells us that the socks cost $3 each and the water bottles cost $2 each. So the first thing we're going to do is formulate, which means we're going to write the formulas. So because it says that she needs at least 200 items, we're going to say that X is number of water bottles, Y is pairs of socks. So the water bottles she buys plus the socks have to be greater than or equal to 200. She needs at least 200 items. Then, using the information about how much each costs, the water bottles times $2 plus the socks times $3 has to be less than or equal to $500. That's the most she can spend. Next, what we're going to do is then graph those systems of inequalities. So here, they graphed them, and you can see that there's a tiny little area where they overlap. So Malia only has a couple numbers to work with here. It's not as large of an area as some of our other problems we've seen. Any of the points in here would work. However, again, because this is a real world problem, we need to think realistically, okay? Malia could buy any number of combination of water bottles and pairs of socks, but she has to be careful, okay? Because she has to sell these. That's how she's like raising money. And you have to think that it's not just all water bottles that someone's going to want. She's probably going to need a nice even distribution of both. So like I said, she could buy 250 water bottles and 0 pairs of socks, but a more even distribution of items might be preferable. So you would have to think reasonably about what would make sense. I probably wouldn't want to pick the number here or here, because that means I'm not going to have any of the others. You're going to want something kind of right in the middle here for realism. All right, so now you're going to give this a try. So we have the same problem, we have the same graph, and they even gave you the inequalities here so that you can see them. But you're going to go ahead and use this graph to determine if Malia could buy 75 water bottles and 100 pairs of socks to meet her criteria. Remember, well, yes, I can plot the points on my graph and to see if that's correct. Because this is such a small area, it might be helpful for you to actually use these as points, X and Y, and to sub them into my inequalities to see which one would work. And that is all that we have, ladies and gentlemen, a short, sweet video for you so that you can understand how to graph systems of linear inequalities. To be perfectly honest, it's very similar to 4.4. So if you understood 4.4, this should really be just a very easy way to put, 2 lines together. If you are struggling with graphing inequalities, as usual, please go and seek some help. You can come and talk to me. You can go and talk to someone at home. You can use paper online, but definitely reach out and see if you can get the support you need, because knowing how to graph one inequality on a coordinate plane is really the main focus of this lesson. You just have to do it twice, okay? So this is our concept summary so that you can understand that we're basically just graphing these 2 lines, and the double shaded area is your solution. Okay, so I'll see you back at school.